Okay, so we're going to talk about the HMP Shunt, or it's just called PPP. And it's just how we make the ribose 5-phosphate to make pyrimidines and purines. So this is glycolysis, that pathway. So we're going to get to glucose 6-phosphate. And this branch is called the oxidative branch. So we're going to go from here, and we're going to have NAD, pH. And I'm going to put stars next to the things that we have to know. It has a bunch of extra information on it. But something to note is that we make NADPH here. And that is done by glucose 6-phosphate dehydrogenase, okay? We don't need to know this intermediate or this. We need to know that carbon dioxide is released. And that we get NADH from it. But the end result is that we get ribose 5-phosphate, which is that sugar. Some things to note is that it's inhibited by its product right here. So this will stop if we already have NADPH. NADPH is only in the oxidative branch, and it's irreversible, and it produces carbon dioxide like I mentioned. So no matter what, this is going to happen. If we were to continue down glycolysis and end up at the GA3P, we would notice that we have GA3P and then two fructose 6-phosphate molecules. So 3 total. And these are reversible reactions, and they will make 3 ribose 5-phosphates. So just think 3 and 3. That they will make the total amount that what we need. Technically, this is a 6 carbon, so that's 12. This is a 3 carbon, so that's 15. Ribose is a 5 carbon times 3, so that's 15. So 15 and 15 will add up. So this is just the explanation. 2 molecules and then 1 molecule equal 3 molecules. So something to note about NADH and NADPH is NADH is normally used for oxidative phosphorylation. NADPH is usually used in the synthesis of other molecules such as fatty acids, steroids, sugar alcohols, hepatic xenobiotics, or just drugs that are digested in the liver, and the reduction of GSSG, which I believe is an antioxidant. And so the reaction that we need to know is we have this glutathione, and it reacts with a peroxy acid. So we have glutathione peroxidase, and we're left with GSSG, which we had mentioned down here. And we get left over with H2O and alcohol. So on the flip side, if we wanted to get back to the GSH or the glutathione, what we do is we use that GSSG, and we use that NADPH, which we had mentioned earlier, is created during the oxidative branch. We use glutathione reductase, and that will get us back to our original product. To our original reactants. So the biggest question is, what happens when we have a deficiency in this, right here, this guy, glucose 6-phosphate dehydrogenase. It's actually the most common deficiency in humans. And what that would prevent is us being able to make NADPH. Obviously, we need NADPH because it helps with malaria. It helps, but because we have this deficiency, females will have an increased resistance to malaria. But the deficiency that we receive is a hemolytic anemia with low GSH levels. And then some other things make it worse. So primuclean, sulfa, and fava beans, which is a dietary thing that we can eat, These lower those GSH levels, which would make it more likely for us to have a hemolytic anemia. So that's pretty much the HMP shunt, or PPP is what it's called.